Good morning, everyone. My name is Doug Dacre. I'm wireless consultant for Prodec Networks. I think we just about have everyone on, or we have a few more people joining. So just while they're joining us, I appreciate this. There's quite a lot of you already customers of ours, know us well, know me. But we've got some people on the call who don't know of Prodec, don't know who we are. So just for them. Prodec, we're based in we're all sat here in Twyford at our head office, part of a group called the Barstone Group, which is based of three companies. There's Network 24, who provide local wide metropolitan network infrastructure. There's SCT, who are a channel only support company and provide support to some of the largest organisations in the UK, including the NHS. And in fact, they support where the vendor has told you it's end of life, which is quite a good value to add. And there's Prodec. We are the public facing part of the business, split up into 5 divisions. So we provide enterprise. So we provide data center predominantly through HP. We provide servers, which is Dell, HP, and lots of others, and we have lots of engineers who have all the qualifications to go with that. Then we have our network division where I sit, and lots of others where we do wireless with Meru, we do Cisco, we do HP, we do security with Palo Alto and Juniper and lots of others. Then we go into unified comms where we provide IP telephony. SureTel is quite prominent in there, and then we have others as well. And also we have a hosted division where we do the hosted, the cloud-based services, business in the cloud, and on from there. So I think we've now got pretty much everyone on there. So I'm going to shut up now. We have with us today Rob Leggett. I've known Rob for quite a long time. Rob is not only what I would consider to be a real expert in Meru, but a real sort of shining light in the wireless industry. And he does. Well, I certainly learn something every time I speak to him. So I won't talk anymore. I'll pass you on to Rob. Just one other thing, you'll see in your right hand column there's a question box with a cursor flashing away. If you do have any questions during the presentation, please feel free to pass them over. Rob will do one or two things. He'll either answer them in turn if he feels there's a quick answer to it, or there will be a section at the end for questions and we can take them then. There is, however, quite a lot of people on the call today, so if your question doesn't get answered during the presentation, don't worry, we will pick up all the other questions afterwards and send you an email. So without further ado, I will pass you on to Rob.
Thank you, Doug. With an introduction like that, I'm going to have to do a reasonable job of this now then. So I can't make it go now. Sorry, having technical difficulties there. So what we're going to do today is we're going to have a look to start with, at how teaching and learning has evolved over the years and evolved using technology, and how that technology has become more and more wireless, and so wireless is becoming mission critical to what we're trying to do in the classroom. Then we're going to look at what wireless is trying to do, or what teaching and learning is trying to do over wireless, and why that's a difficult application for wireless to achieve, and why we need a different technology perhaps from the other wireless that is out and around. Then we're going to have a look at why Meru's technology is fundamentally different from other technologies, and understand why that makes it fit for purpose for the application, which is teaching and learning. And then we're going to have a little look at, or provide some advice on how to avoid disappointment when you choose your wireless. So make sure that you end up with something that meets the requirements of of your particular school. So teaching and learning has been evolving, and it's been evolving with IT. And the idea is that often us people in IT forget about is that the goal is to improve the learning outcomes of the students who are involved. When we started deploying devices in schools, they were just for the teachers to start with. So the laptop for the teacher, the wireless network was not particularly important. The idea was that teachers would be able to download files, perhaps do emails, but very little involvement with the pupils. A little later on, laptops were introduced in classrooms to help engage the students, and we've had since the success of that, we've had more and more devices put into larger parts of the schools, and now we're moving towards a one-to-one environment where we have a device for every student. They're used in every lesson, and the ICT has become embedded in the way we teach and learn. And the idea is that the ICT brings a higher quality of engagement to the pupils, and it brings more engagements every day for a longer period of time. So it enables us to not only deliver the curriculum, but it helps engage students with research and to be more independent and more collaborative in the way they learn. Okay, so somewhere along the line, ICT has become mission critical. We can't get by without it in schools today. One of the things we find is the devices that we're deploying for teaching and learning either don't have a wireless network card in them, or which would be the case for most of the tablet devices, or they have, or the schools don't have a wired point. So many of the laptops we have in schools, they do come with a wired interface on them, but we just don't have enough network points. So teaching and learning with ICT has actually become teaching and learning over wireless. And if we take a little look at that evolution, it's becoming harder and harder for wireless to cater for the demands that we're putting on it. So when we had just one device per teacher or a few devices in the classroom, it was very simple for the wireless systems to provide a quality experience for the users. But the first problems came around when we started deploying whole classes full of devices. So that would be the laptop trolley. And schools have found that the individual laptops shared by students were a great aid. So giving out a laptop to each student must be good. And what we found then was quite often it was a disappointing experience for schools, because they would hand the laptops out off the trolley to a class full of excited pupils, and we found that performance was very poor. So it might take a class of students 10, 15, 20 minutes to get logged in. But we got over those problems, and the next thing we started to do was to put more and more devices into classrooms, into more and more classrooms. So as we moved on, we had whole classes of devices in every class in the school, and we found then that because we were needing to put more and more access points in the school, it became difficult to get a reliable performing wireless network. So teachers would see not only it taking a long time to get logged in, but they might find that not all the pupils could get logged in, and when they did get logged in, pupils' devices would drop off the wireless network. And the teachers spent their time looking after the wireless network rather than trying to teach. And then the next stage was when we started to introduce tablet devices into the schools, and the students retain those tablet devices as they walk around the school. And the thing that we're finding now is that as the students walk around the school, the performance that they're getting from their device changes. So they might be in a classroom having excellent performance, and the bell goes, and they'll walk to the next classroom and find that they can't do the things that they had been able to do in their previous class. So what we need is wireless that works. The goal for a wireless network is that the teachers just shouldn't have to think about the wireless at all. It needs to be reliable. It needs to perform with the density of devices that we have in the classroom, and it needs to work across the whole school, not just in the classrooms, but also in the corridors, the shared spaces like canteens and libraries, and it needs to work with the density and the mobility that we're starting to see across the schools now. Okay. And what we're going to do in a minute is to talk about some of the technology that we need to achieve this. And we always there's two ways of proving that something works. We can either show you the technology and describe the technology, or introduce you to other people who are using the technology. And what we've done is Meru's installed in about 2,500 schools in the UK now. Many of those are secondary schools. Many of those are now at the point where they have one device per student. And what we've done is we've created a number of case study videos which are available online for you to have a look at. And we have a bit of a saying, which is that every one of our customers, we really want them to be happy enough with their equipment for them to be a reference site. So wherever you are around the country, if you want to get in touch with us, I'm sure we can introduce you to somebody who's already running a Meru network to do something that's very similar to what you're doing at the moment. And the map on the right there shows kind of shows the locations of the people we have. So these vary from you'll see primary schools, state secondary schools, private secondary schools, academies, free schools, colleges, universities, every kind of educational establishment that you would come across. And if you look on the left-hand side there, we've got a huge number of schools in Ireland that are using Northern Ireland that are using Meru, and this is down to one of our resellers has recently begun deployment of a cloud-managed wireless network. So Northern Ireland went out to tender and evaluated the wireless networks of all sorts of manufacturers, and has decided to deploy Meru on a countrywide basis. And then the key thing there is, if you are looking to deploy wireless in all of the schools in the country, you're going to take a bit of trouble over the evaluation and make sure that you have exactly the right product to do the job. So let's have a look now at the fundamental differences between Meru Wireless and the other wireless technologies that are out there. The first thing, before we can understand how Meru works, we need to understand how other technologies work. And the term we use for other technologies is Microcell. And one of the fundamentals of Microcell technologies is that access points need to be on different channels. So no access point is allowed to see another access point that is on the same channel as that access point. And that would be, it wouldn't be too difficult, but in the main frequency band that's used in schools, which is 2.4 gigahertz frequency band, we only have 3 channels to choose from. So we need to do a coverage jigsaw of access points where we cover the school, often with an access point in each classroom, but in such a way that no access point can see another access point that's on the same channel. And what you find is that when you're close to an access point, so in the red area on this diagram, when you're close to an access point, you'll connect at the highest possible speed. And as you move further away from the access point, you'll connect at an ever lower speed if you're trying to connect to that access point. So what we need to do in schools where performance is a key problem is to make sure that all the users are sat within this high-speed zone. And the problem with that is that these zones of lower speed are although they're not so much used for connection, they are able to interfere with a neighbouring access point. So to get performance, we want to have our access points close together so that everybody can be sat in this high-speed zone. Then if we have an access point per classroom, so in this classroom we'd have an access point on channel 1, and in this one on channel 6, and in this one on channel 11, then we're back to channel 1 here. Those are our 3 channels. You find that this access point and this access point are able to interfere with each other. So the coverage that you get from any given access point is not as good. You can see over here that one access point is providing excellent coverage in a whole classroom. Over here, that one access point is being interfered with by another access point. So even though we have an access point in the classroom, you get areas of poor coverage in that classroom. So what we need to do to get around that is move the access points further apart. And you can see that we have a problem, which is that the two main design criteria for designing the network are conflicting. So Meru has fundamentally different technology. So rather than having the access points on different channels, Meru is able to put all of the access points on the same channel and set the access points so that they operate on their full power settings. And because Meru manages the transmissions of the access point and the devices so that there is no interference, we're able to create this a single seamless area of coverage across a whole school, which enables all the students to sit in an area which is the highest possible data rate without having interference from the other access points. So we achieve in just one channel the performance across a whole school that you would normally expect to be able to achieve if you were using all the channels. And that leaves us the other 2 channels free to do other things with them if we want to. So as we get more and more devices in schools, or if we're looking at some of the higher performance requirements areas such as the Learning Resources Centre, or maybe handling hundreds of pupils in a conference centre, or for exams, we're able to deploy the other 2 channels to give us multiple networks in any space to deliver scalability. So that's handled coverage with performance and reliability. The second piece is how do we handle high densities of devices? And Meru again has fundamentally different technology. With Microcell technology, the devices are in charge of when they're going to speak, and they negotiate between themselves which device is going to talk next on the network. And my analogy for this is if you were to take a class of students to, say, the London Underground and suggest that all the students make their way through the turnstile, but you leave the students in charge of that decision, what you'll find is there's a big fight to get through the turnstile, and individual students can get, or 2 students can try to go through at the same time, and they get stuck in the turnstile. So we have a very inefficient method of deciding which student's going to go through the turnstile next, or in the analogy, which device is going to speak next on the network. And what you find is that as you get more and more students or more devices on the network, the use of the network becomes less and less efficient, to the point where you might be, with a whole class of students, you might be 10 or 15% efficient on the use of the network. And Meru instead puts the network in control of when devices are going to talk. So the network is controlling transmission, and in the analogy it has the effect of lining the students up and saying it's your turn to go through the turnstile, now it's your turn to go through the turnstile. And as we get a higher and higher density of students or density of devices, we get a higher and higher, or we manage to maintain the same levels of efficiency on the network as we did when there were just a few devices. So as you get more density, the network remains efficient with a Meru solution. The third key area that's beginning to deliver problems in schools now is the problem with mobility. And this is where you have students who retain their device and carry it around with them all day. And with tablets, the tablet devices are always on devices. So you never shut the tablet down is the idea. And what happens is you might, I've got laptops here, but tablets is the same. You start in a lesson and you're attached to an access point that you're sat right beneath. So you will have a very high connection speed, and you should find that you get good performance. But when the bell goes for the end of the lesson, you walk out of the classroom and your device is in charge of deciding when it's going to change and connect to a new access point. So as you walk out of the classroom, the device will be saying to itself, I'm connected to this access point, I'm connected at a speed of 50 megabits per second, I'm perfectly happy. And when you get into the new classroom, even though you can be sat right underneath an access point, you find that you're still connected to the access point in the first classroom, but now you might have a much lower connection speed, so maybe 3 megabits per second or 5 megabits per second, or sometimes even less than that. So just by the very act of walking around the school, you've decreased the performance of the network for yourself. But in schools, what we find is all the students are moving around the school virtually all of the time. So that mobility can ensure that virtually every student is connected to the wrong access point most of the time, and we find that destroys the performance of the network. What happens with Meru is the network is put in charge of which access point you're going to connect to. So as the device moves out of the classroom, it will the network will be measuring the signal strength between every access point and the device, and as it becomes so that the device is in a room or in a location where it gets a better connection from a new access point, the system will ensure that the device is connected to that new access point. And this has a huge difference in performance. It makes a difference of perhaps of a 150 megabits per second connection, where other systems would give a 5 megabits per second connection. So what we're doing there is three fundamentally different things. We have a single channel environment where every access point can be put on the same channel, and where we make sure that we have no problems with interference. The single channel architecture gets rid of interference and all the problems of reliability that are caused by interference. The second thing we're doing is we're putting the network in charge of when devices are going to talk, and that makes the network more efficient as we have higher densities of devices. And the third thing that we're doing is we are putting the network in charge of which access point devices talk to. So as the devices roam around the network, we continue to have the highest possible connection speeds and the best possible performance. So usually this is a much longer presentation, but we've kept the technical differences to the technical side of it as small as we can. What we want to do now is to move on to how to avoid disappointment when you choose your wireless network, because making that evaluation and choosing the network that you're going to have is very important. So we often say choosing the wireless network is is a bit like painting a school. When you choose how much wireless you want, you need to define that very precisely. What you find is if you were painting the school and you got a supplier in and you said, I'd like you to paint my school please, they'll give you a quote for that, and what you'll end up with probably is a very thin layer of paint across the whole school, which is precisely what you asked for. And if you want more than that thin layer of grey paint, then you need to specify much better what you ask for. You need to say how many coats of what kind of paint in what colour in what area. And it's the same when you're trying to define what kind of wireless network you need. So what we would want you to do is to document how many devices and of what kind of device you're going to need in what area. So you need to specify to the supplier that you will have, say, 30 laptops in every classroom, and that those laptops are 2.4 gigahertz only, or 2.4 and 5 gigahertz, and that you're going to use them to do things like browsing the internet. If you have local video servers, then you should specify that you'll be streaming high definition video to simultaneously to those devices. We need you to specify where the devices are going to be used. More and more now we're finding that devices are used in the classrooms, but devices are also, the students are using the devices in between lessons as well, so they're extending their working day by using the devices in the corridors, in their breaks. So we need to specify where we want the coverage and the performance that we require for the coverage, and also need to specify that the devices are going to be mobile, and that we need to be able to run these applications with devices that are mobile, and that they need to work wherever we are around the school, regardless of whether they've just moved or not. So we would suggest that with the specification, rather than just saying come and do Wi-Fi for my school, we need you to document your goals. So specify precisely what you need in terms of coverage, in terms of device density, in terms of the mobility of the devices, the types of devices that you have on your network, and the applications that you want to run those on those devices. And then you should evaluate against that specification. And that's a difficult thing for a lot of schools to do, because they're trying to plan for a time in the future. It's the long-term goals. You know, we will end up with a school that has one device for every student, but at the moment we've only got perhaps a device for a third or a quarter of the students. So what we need to do is to make sure that the tests that are run are a realistic test of where you want to be. So always test with the right density of access points, and we would suggest that a minimum of 4 access points is required to run a proper test, and those 4 access points should be in adjacent classes, so that you see the problems of interference that you get with there only being 3 available channels. And we would suggest that you test with a realistic device density. So it's not just 30 devices in one classroom. We want you to test with 30 devices in each of those classrooms, if possible, and test with realistic applications. So if you're going to be streaming video, then let's stream video in the test. And if you're going to be running with iPads, or you're going to be running with laptops, and the laptops are going to be logging into a Microsoft system, let's make sure that you do those things that you will be wanting the network to do as part of the test. And then the final piece is to test with device mobility. So it's no good just running the test with the device in the classroom. You need to up sticks and move all the devices a simulation of when the bell goes. So move all the devices to a different classroom and make sure that they're still able to perform in the way that you need them to. Then we get the question, we very often get the question, how many access points will I need for my school? And this is the same question as how many pots of paint am I going to need to paint the school? It depends how thickly you want the paint, the school covered by wireless network. And we would suggest that you start by designing for performance. So wherever there's a classroom where you will require whole class learning, you're probably going to need an access point for that classroom just to satisfy the performance requirements of the devices in that classroom. So what we do is we take a plan of the school and we put access points in the locations that we need them from a performance point of view. The second thing we do when we've done that is we design for coverage and for reliability. So that means we need to design to make sure that the access points we've put in cover not only the high density usage areas but all of the rest of the school areas that we need covered, and that we don't have too much noise from other access points that will cause us problems with interference later on. Obviously, with the Meru solution, we don't get the interference problems, but with other solutions, if you design for density, you can find that and design for performance, you can find that the reliability is destroyed because there are too many interfering access points. So the usual way to do that is with a heat map or with a site survey. What this is a heat map is a desktop simulation. So we take a plan of the school and we mark on the school the different walls, different wall types that you have, and then we can put an access point on the plan, and the system will simulate the coverage that you're going to get from that access point. So you can see here, as you get further away from the access point, we have a lower connection speed and a lower signal strength. But when we do these surveys, the desktop surveys, the information that you get out is only as good as the information that you put in. So you can see here, there's a huge difference. If we have concrete walls, we get one level of coverage, whereas if we have dry walls, a single access point may well give us coverage across the whole school. So you could have said, I need, if the specification in this example was the school needs to be covered by wireless, then you would achieve that with one access point. So that single access point in this school made out of dry walls will cover the whole school. But if your school was made from concrete, it comes nowhere near covering the school. And you'd actually find here where we had a single access point to cover a whole school, even though we have coverage, you wouldn't have the performance that's required to do the job. So what we often find is schools say, just do us a heat map, will you? And they don't give us any information about the kind of devices, the number of devices, and the number of pupils. And in that case, the output is pretty much the same as if we just coloured in the paper or painted the paper. Without enough information, we can't design a network which reflects the performance that you're going to need. So as we've gone over the technical differences between Meru and other technologies, and we've gone over some of the information that you're going to need in designing the network. And this is all about the RF side of the network. So how do we get a network that is going to be high performance and it's going to be reliable at the same time? So it's going to achieve our teaching and learning goals of teachers not having to worry about the wireless network at all. So we've covered that. the next questions that we would ask people to consider, and actually we're not going to go through these today because I think half an hour on a webinar is plenty. The next questions that we usually ask to consider are: how do we handle guests on the network, and how do we handle the growing phenomena of students and staff who are bringing their own tablet devices and their own laptops and their own phones into the network? So how do we handle BYOD? How do we ensure that we have the right levels of security on our networks? And the final piece is many schools are having more and more Apple devices on their network, and a lot of the Apple devices, so things like Apple TV and Apple printers, were really designed for a home environment. And in the home environment, we're usually having an environment which is a single subnet environment with very few users and very few devices, which is the opposite to what we find in the school. So there are things that are required in schools to make the Apple AirPlay and Apple AirPrint resources work. And then finally, what do we do if we have groups of schools? So how would we do things differently if you are a group of academies or a local authority looking to deploy? And Meru has specific solutions for each of those areas, and what we'll probably do for those who are interested is run another webinar to cover those items. So quick review. Wireless has become mission critical because we have embedded ICT in all of our teaching and learning, and those devices are in many cases don't have a wired point on them. We have teaching and learning is a very difficult application for wireless because we have a very high density of devices. The devices are mobile, and we're trying most of the time to send multimedia data to those devices, which is the hardest possible things that we could do. Meru is fundamentally different from the other technology. It runs on a single channel rather than multiple channels, so we're able to get a high connection speed without having interference, which causes poor reliability. And we put the network in charge of which access point a device is going to connect to, when it's going to change, and we put the access point in charge of when the devices are going to talk. If you don't want to get too deeply into the technology, we've got 2,500 schools in the UK have done this already, and we'd be delighted to introduce them to you, or we can show you video case studies. And finally, as a summary, we just want to make sure that when you're looking to deploy a wireless network, you write a specification which defines what you're going to use the wireless for, where you're going to use it, how many devices, and make sure that the equipment that you purchase meets that specification. Thank you.
Thanks, Rob. That's very, very good. What we're going to do now is we're going to show you a short video which is a demonstration of high density with Meru. After this, we'll be taking questions. So I see we've got a few questions coming in already. If you do have any more questions during this video, then please shoot them across to us, and we can have a look and answer them then. Okay.
let's take a quick look at the dashboard, make a live call, and see what happens.
Yeah, so I hope you can hear my voice. This is a voice call while we have hundreds of devices connected in a high-density network in a multi-layer Meru wireless LAN. And what you're hearing is crystal clear voice in the presence of video, a lot of background traffic, and all the devices being connected. Hi.
Under the same conditions, video continues to run flawlessly. Even with over 100 megabits of background data, the video continued to run. Jumping on any platform in the entire test, we can bounce around from popular site to popular site, and you can see the performance continues to be snappy and quick.
I think everyone that that knows wireless always agrees that that demonstration is quite incredible, actually. But anyway, we got lots of questions. Like I said, there is lots of people on the call today, so there is quite a lot of questions that we're going to have to come back to you guys on. But there is a couple of topics that keep coming up over and over again. Firstly, will the presentation be available afterwards? Absolutely. We will send you all a link to this presentation so you can have it. So you can show other people or run through it again as you wish. There's also some questions around what I'm going to put to Rob, actually, and is around how Meru or how Rob would recommend we deal with guest access. Also, there's a few questions around Apple devices. Interestingly, around Apple TV. A lot of you guys seem to be looking at Apple TV and AirPrint. And also what Rob's opinion is on BYOD in education.
Nice easy ones then. So if we take those one at a time, the first is about guest access, and schools are handling guest access in a number of different ways. It depends very much who the guests are. But we have who the guests are and when they want to come onto the network. So we have different classes of guests. It's things like the after-school clubs for adult education, as well as day-to-day guests coming into the network. And one of the key things that is changing in the way that guests are handled is that in the old days, it was good enough just to have a password. So a username and password for the guests. It might be guest one and password one as the username and password, and you hand that out to everybody who comes into the network. But with things like the Digital Economy Act, it's becoming more and more important that we understand who is on our network and what they're trying to do. So we need to find ways of provisioning individual users with their own username and password, and keeping a track of what those people are doing when they're on the network. And we can either pass that job on to the receptionist in the school, which could keep them very busy, or we can find ways of delegating that either to the users themselves or to the people who invite them into the school. And Meru's got some very clever guest access software which enables us to handle providing individual usernames and passwords to every user who's on the network, to delegate that task so that even if we've got a conference for 1,000 people in the summer, it's a very simple task to do that. It's not taking too much of any one person's time, and we need to and then it keeps track of who's been where and what they've been doing on the network, and we can handle that one separately. The second thing is about Apple devices and Apple TV, and really there's two sides to this. The first is to make sure that we provide enough reliable bandwidth to ensure that the network can handle all of the TV requirements, and I think that's what we've been talking throughout this entire webinar. The second piece is quite a technical piece, and it's about handling all of the broadcasts that that Apple produces for AirPlay and AirPrint. And there's two schools of thought. One school of thought is that you need to block them because they are broadcasts. They go everywhere, and they're the amount of broadcasts is proportional to the number of devices on the network and to the number of services. So as you get lots of devices and lots of services, you get an incredible number of broadcasts. So one thing is just to not let them through the network, but then you don't get access to any of the resources. So Meru has a gateway product which enables those broadcasts to be propagated across the network, so they can go between subnets. But the gateway also is able to limit the number of broadcasts on dependent on individual users and the types of devices and the location. So it's who they are, what device they've come from, what time of day it is, where they are in the building, as to whether or not they're able to receive a particular service. So Meru has some very clever technology to handle the Apple TVs and Apple printers as well. And the third is a piece about third question, Doug, is bring your own device in education. We're seeing more and more bring your own device everywhere we go. The students have devices that they're being asked not to bring into school in some places, and other places they're being encouraged to bring their devices into school. It is a great way of harnessing the parents' spending power, provided that we can keep control of those devices and when they're used and where they're used. And again, Meru has technology that enables us to use the school's authentication systems and security systems to take control of the devices and make sure that they're only being used where we want them to be used and when we want them to be used.
Okay, thanks, Rob. Just from myself, we get asked this. I get asked this quite a lot when I go into schools. We find ourselves when we're installing Meru is we tend to, if they are putting guest access in place, certainly for the kids, it's VLANed off, so it's nowhere near the network. So there's some good security going on there. But that was great, Rob. Thank you very much. If any of you guys want to have a more technical, in-depth conversation than that, then you've got our contact details. Please let us know. Rob is. I mean, and I don't mean this in a derogatory way. Rob could literally talk all day if we'd allowed him to go technical. So if you want to have those technical conversations, please do come to us, because we're more than happy. If we can't answer them, Rob would certainly be happy to. And anyone who hasn't had their question answered, and I see there's quite a few of you, we will come back to you. We will send it by email, and you will get an email to the presentation. So thank you very much for attending. and wish you all well. Have a great day.